Welcome to Ask and Learn.
In this problem, we have to compare how various elements would bond to hydrogen. And we're going to consider the different chemical properties that comes with this, such as oxidation state or comparing the similarities between ionic radius or lattice energy. So the first part that we need to do is calculate the oxidation state of hydrogen. Now, what we see here is that hydrogen is bound to group 2A elements. And we know that group 2A elements are always a positive 2 oxidation state. So we can set up this very simple equation to find the oxidation state of hydrogen. So we know that plus 2, remember, positive 2 for group 2A, plus 2x equals 0. So that means that 2x must equal -2. And this is the way that our compounds would be neutral. So then we would solve for x and we would get -1. So the oxidation state of hydrogen in all of these compounds is -1. And now we have to discuss the relationship between bond length and lattice energy. Lattice energy simply is talking about the energy of a solid state structure. So lattice energy is directly proportional to 1 over the bond length. So what that means is that as bond length increases, the lattice energy decreases. And what we see in these group of elements is that beryllium has the smallest ionic size. So we're going to see that the beryllium H2 is the shortest bond length in this list, and so it would have the highest lattice energy. And now, just to talk a little bit more about the bond of the beryllium H2, it requires 3,205 kilojoules of energy to break the bonds of this compound into all of its ions. So that would be beryllium 2 plus and hydrogen 2 minus. And now, let's talk a little bit about comparing these different compounds we have. So what we see is we're comparing zinc and manganese when they're bound to H2. And what we see here is that the lattice energies and the charges of both of these compounds are relatively the same. They're very, very similar. So what this means is that the charge of these are the same, the lattice energies are the same, and that must mean, without a doubt, that they have a similar ionic radius, because now we're seeing this relationship between ionic size, charge, and lattice energy, and even bond strength and length. So this is why we see zinc and manganese to be similar chemically bound compounds. So I hope that this problem helped you understand a little bit more about analyzing how different elements or metals bind to hydrogen. And then we can use the information such as lattice energy and bond length to understand how these different compounds are different or the same from one another.